Okay, so you're asked to evaluate a limit and there's an integration. So what I would recommend to do here is just see if you can do the integration. So let's write this down. Limit. I'm going to factor out the constant, which is 1 over n, ln n. We're not talking about the limit, we're talking about the integration now. There's going to be an integration from 1 to n of ln x dx. You should be somewhat familiar with the antiderivative of the natural log of x. I'm not going to say you're going to remember it long term, but you should be able to get it, all right? So I think we just did this a little while ago. Let me write this over here from the side for you, just to remind you what we did. We used integration by parts, and I'm going to put the parts down for you now. So I'm going to say, let's see, it's going to be, let's write this on the side for you. It's going to be u dv equals v u minus v du. All right? So let's write this down, see what we can do over here. And I'm going to say u is equal to ln x, and du would be 1 over x dx, all right? And then I'm going to write down dx, whoops, I put dv down, is equal to dx, and v equals x. Well, let's see if we can write that down now. And what do you get over here? This would be equal to, well, u times v, so that's x ln x, minus the v, well, the v is x, and the du is 1 over x dx. Well, it doesn't look that bad to do. That's x ln x. That's minus the integral of 1, which is going to be x, plus some constant of integration. All right? So I'm going to say that's not a bad integration to do. That's when you may not, it's when you may be able to remember. Let's write this over here. Limit n goes to infinity, 1 over n ln n times, well, let's write the antiderivative down without the constant, by the way. And then we're going to evaluate that from 1 to n, all right? So looking at this thing over here, I'm going to continue. This is still a limit problem. I can't do that yet. N goes to infinity. This is 1 over n ln n. And let's do the evaluation. It's at n, right? So it's going to be n ln n minus n. And now it's going to be minus the lower limit. Well, if I put the 1 there, I get 1 times the natural log of 1. Well, the natural log of 1 is 0, so I'm not going to write that down. Then minus a minus 1 is plus 1. All right, looking at this thing, can I do that limit? I don't know, let's take a look. Limit as n goes to infinity. And what do you get there? We're going to distribute this across those 3 terms, and you're going to get 1 minus 1 over ln n plus 1 over n ln n. I can certainly do that limit now. The limit of the first term is 1, that's 0, that's 0. So this limit's going to be 1, all right? So just a reminder, as we go through these problems over here, we do present work for you. I'm not looking at my work, by the way, when I do this over here. But the bottom line is, you know, if you get stuck on something, it's nice to have work to look at and see if you can figure it out. Now, certainly, does the work look like I've written over here? I think so. So I think I got this step done. I think I put this down. I just didn't talk through that antiderivative because I remembered that antiderivative, by the way. And then I evaluated, I got that written down for you. And then I do the limit, right? The limit's rather straightforward to do, right? Again, you may look at these things and think they're impossible to do, but that's simply not the case, by the way. What does that mean? Try to think about the problem. Try to do the problem. It's going to have an answer. Typically, it's going to have an answer that's pretty easy to come up with. Thank you.